morning, afternoon, or evening, depending on which time you watch this video. My name is Mohammed Zain, and today I'll be presenting my ISM project that I did throughout the fall 2020 semester, underneath my teacher, Mrs. Durant, and my mentor, Mr. Orenberg. At the beginning of the semester, I came up with a question that I wanted to answer throughout my independent study, which was, how can one manipulate data to find correlations and causations? Before we move on, I just have a quick disclaimer. Some of the information that is within this PowerPoint came from outside resources, such as articles or from my mentor, and I didn't come up with all the ideas or information on my own. Now then, let's ask the question, what is ISM? ISM is essentially an advanced academic course that gives students the opportunity to be mentored under a professional under the career choice that they chose. At the end of the year, the student will make a product to show their expertise and knowledge within that topic. For my ISM project, the study career that I chose was a data science engineer. A data science engineer essentially is an aspect of data science that focuses on the application of data collection and analysis. He/she will construct, test, maintain these large databases or large-scale processing systems. My project topic that I chose was data science. More specifically, the manipulation and analyzation of data to find correlation. The reason I chose this topic was because I've been doing programming for 3 years and I want to continue that. And secondly, I'm most likely going to become a data scientist or a computer scientist in the future, so I want a head start. 3 key points that I want to talk about my topic is the fundamentals of data science, how it is used in the real world, and the need of packages. Let's start with my first key point. Fundamentals. Early on, I learned Python is essential to data science, and it's a great starting point for learning about the career for beginners similar to me. A second fundamental people need to know is basics about programming. I, fortunately, knew about Java beforehand, so I could just translate my basics that I learned from Java into Python, just using different syntax or grammar. And lastly, people need to know about packages. Packages are essentially external tools that people can import into the Python programs to help them do their tasks. Let's move on to my second point, real-world applications. Now, a data science engineer isn't just sunshines and rainbows. It has its own problem, such as communication. There's a huge communication problem currently with data science engineers and managers and executives, and this can lead to many problems. Another thing people have to keep in mind is that data science engineers have to be multi-talented and be good at multiple languages and multiple tools at the same time. And lastly, the field itself is very demanding and complex. People are required to do a lot of research and a lot of tasks in a short period of time. My third key point is packages. People, including me, don't understand how packages are very essential in data science engineering. In my final product code, I used 4 different packages, including NumPy and PyChart, which were very functional in my code and gave me the ability to graph and use linear algebra. In our ISM course, we did 3 planned research topics. My first research topic was, what is data science? Data science essentially is the manipulation and analyzation of data to find correlations and causation. My second topic was the difference between data scientist, analyst, and engineer. I essentially learned that a data scientist collects the data, engineer maintains the data, and an analyst analyzes data. And my last research topic was the problem of data science in the workforce. And after extensive research, I learned the main problem was communication between STEM fields and the business side. We also had a current event assignment within our ISM course. My current event article was Data Science and the Art of Persuasion. The article basically talks about how even though there's a demand for data science engineers, the demand is stagnated because there's a communication error between data scientists and their managers and executives. The final product that I chose to make is a data science program that basically inserts video game datasets and packages and organizes those datasets into different groups. From those groups, it finds correlations and displays those correlations. My code, which is running on the top right-hand corner, outputs a graph shown on the bottom left-hand corner. In that graph, it organizes the genres and platforms into different groups, and it basically lets people see which platform releases which type of genre of games the most. This can help consumers choose which type of platform they want to buy. With my product, I also made 10 different artifacts, which are computer science vocabulary, schedule/timeline, background information on computer science, programming techniques, samples/progress code, computer science theories, computer science datasets, problems and solutions, diagrams, and simulations/tests, all of which can be found on my Weebly. In conclusion, the main thing that I learned from my mentorship is how to program in Python and how that relates to data science. What I hope to learn next semester is how to use the packages plotty and plyda and how to make my own datasets. Before we conclude this, I'd like to thank you for taking the time to watch this and to thank my mentor and Mr. Rent for allowing me to do this. If you have any questions about my presentation, feel free to contact me from these contact informations. And before I go, here are the citations that I used throughout my presentation.